Hello students, today we're going to learn section 8.3, conic section, hyperbola. A hyperbola is a set of all points in a plane whose distance from two fixed points in the plane have a constant difference. Alright, key parts when graphing. Find the center, diagonal asymptotes, vertices, and focal points. These diagonal asymptotes, we're going to draw a what you call a central rectangle. And this will make more sense when we actually graph. All right, standard form for a hyperbola. It's similar to the ellipse, but the only difference with a hyperbola is that you're going to have 1 plus, 1 minus. So 1 positive, 1 negative. Here is 1 negative, 1 positive. If the radius of x, if the coefficient of this x term is positive, the hyperbolas are going to open up sideways. If the positive coefficient is with the y values, the hyperbolas are going to open up and down. Okay? So if x is positive, if the coefficient of x is positive, it opens up with respect to the x-axis. If the y is positive, then it opens up, the hyperbolas open up with respect to the y-axis. The formula for the focal distance is c squared equals a squared plus b squared. All right, so let's do example 1. Example 1, write equation in standard form, graph and label center, vertices, focal points, and what the conic is. All right, so again, we're starting off with our conic form of this quadratic. I want you to write it in standard form. So first thing, we're going to move the constant to the right side of the equal sign. After that, we're going to group all our x's together and then all our y's together. So I grouped all the x's together, just like what we did in section 8.2 for the ellipse. After that, make sure the coefficient of the quadratics are 1 or is 1. So we factor out a 9. We factor out a negative 4. So when we factor out a 9, this is now x squared plus 10x. This is now y squared minus 8y. If you distribute the 9, you will get back to this. If you distribute the negative 4, you will get back to this. So when you factor out a negative 4, this positive now becomes a negative, because a negative times a negative gets us back to the positive. Next, we're going to complete the square. So when we complete the square, it's half the linear coefficient, and we square it. So this is now 25. And we're not adding 25, we're actually adding 9 times 25. Half of negative 8, the coefficient, is negative 4. Negative 4 squared is 16. So we are not adding 16, we're actually adding negative 4 times 16. So we're adding negative 4 times 16. So now the equation is balanced. Once you simplify this entire right side, it's going to equal negative 36. So all of this here equals negative 36. We completed the square. So x plus 5 quantity squared is equivalent to x squared plus 10x plus 25. Here we have y minus 4 quantity squared. It's y squared minus 8y plus 16. So we completed the square. Now in order for this to be in standard form, the right side of the equal sign has to equal 1. So we divide by negative 36. And now negative 36 over negative 36 is 1. Negative 4 over negative 36 reduces to 1 over 9, positive 1 over 9, because a negative divided by a negative is a positive. And a positive divided by a negative is a negative. This is not in standard form yet because we have to have the entire fraction squared. We only have the numerator squared. So I can rewrite 4 as 2 squared. We can rewrite 9 as 3 squared. So now this is now in standard form. So from here, we can get our center. Our center is -5, +4. -5, +4. The radius of x is 2. The radius of y is 3. So let's plot that. So -5, +4. There's our center. Okay? The radius of x is 2 units. So we move 2 units. We move 2 units. The radius of y is 3 units. So radius of y, we move up 3, down 3. So here's the center. So radius of x, 2 units. Radius of x is 2 units. Radius of y is 3 units. 1, 2, 3. 1, 2, 3. So now we have to create our central rectangle. And it's just making a rectangle. All right, and next, we're going to make our diagonal asymptotes. So you go from this corner to this corner. And you go from this corner to this corner. Okay. Next thing we're going to do is we have to determine, are we going to have the hyperbolas open vertically or open horizontally? To determine that, you have to check which one has a positive coefficient. So if we look at these two here, the one that has a positive coefficient is the y. So that means that we're going to have a parabola that opens up and down. And the reason why it was important to draw these diagonal asymptotes is because it guides us to write or to figure out how wide we're going to make these hyperbolas. All right, so we know that the vertex, it's this point here. So if you look, this is -5, 7. -5, -7. The other vertex is going to be, what is this? -5, +1. And again, I knew it opened up and down because the coefficient of y was positive. Okay? And instead of vertex, I'll just put the plural for vertex, which is vertices. So just let me make that adjustment. So these are the vertices. Next thing to do is we have to find our focal points. So to find the focal point, let me do this here. Focal point, the focal distance is this formula, c squared equals a squared plus b squared. A is 2, b is 3. So the focal distance is 3.6. So we're going to move, the focal points are in the cups, just like the parabola. So from here, we're going to move 1, 2, 3.6. So there is one focal point, So that's one focal point. Make this darker. So this focal point is going to be located at -5, and we went 3.6 units down. So since the center here was -5,4, you take 4 and go down 3.6 units. So it's just 4 minus 3.6. So 4 minus 3.6 is, let's see, 4. So we go from here, we go 3.6 units down. That's going to be, let's see, sorry. This is 1, 2, 3, it's right here. My mistake, I counted from the vertex, from the center. Okay, from the center. So 4 minus 3.6 is 0.4, and that looks like about 0.4. Here, we're going to go from the center, go up 3.6 units. 1, 2, 3.6. So the focal point here is going to be -5, comma, we went up 3.6. So if we're moving up 3.6, you take 4 and you add 3.6, which is 7.6. And this is our other focal point. Last thing, we're going to label this conic. This conic is a hyperbola. So just make sure you write that down somewhere on your paper. So we found the center, we found the vertices right here, we found the focal points, and we're done with example 1. All right, next, let's go to example 2. So in example 2, again, put the constant on the other side of the equal sign. So plus 4, 4, 4 on both sides. Group all our x's together, all our y's together. We factor out this 25 so we can complete the square. Factor out -16 so we can complete the square. Make sure this negative now becomes positive. And then here's the process. Half of -4 is -2. -2 squared is 4. So we're not adding 4, we're actually adding 25 times 4. Here, half of 6 is 3, 3 squared is 9. So again, we're not adding 9, we're actually adding -16 times 9, or you could just say -16 times 9. When we simplify this right side of the equal sign, the whole thing is equal to 400. So 444 plus 25 times 4 minus 16 times 9 is 400. We divide by 400 because we want the right side to equal 1. We completed the square, we completed the square. So we divide by 400 everywhere. So 400 divided by 400 is 1. The center is 2, -3. And this is not standard form yet because the denominator has to be a fraction. I'm sorry, the denominator has to be squared as well. So 16 is the same thing as 4 squared. 25 is the same thing as 5 squared. So now this is in standard form. Our center, HK, is going to be opposite -2, opposite +3. And the radius of x is 4, the radius of y is 5. Okay, so let's plot these points. Okay, center 2, -3. So we're down here, 2, -3. The radius of x is 4 units. So move 1, 2, 3, 4. From here, 1, 2, 3, 4. Radius of y is 5. From the center, 1, 2, 3, 4, 5. From the center, 1, 2, 3, 4, 5. And draw our central rectangle. So again, this will help us draw our diagonal asymptotes. Now, if you don't want to do the diagonal, central rectangle, this is really a slope. So if you just go 5 units over 4, if you just do this, m is equal to 5 over 4, right? Y over x. 1, 2, 3, 4, 5. Across 4, 1, 2, 3, 4. So that's another way to get your diagonal asymptotes. Or I like to do the rectangle. I want to go from corner to corner, including the center. And just make sure it's broken so we don't get it confused with anything else. So this corner to this corner. Okay. All right. So now, since we know that the coefficient of x is positive, the cups, if you will, the hyperbolas will open right and left. So here is the vertex for our hyperbola. And again, the reason why we have these vertical or these diagonal asymptotes, it guides us to figure out how wide we're going to make these cups. All right. So vertices. Just get the location. It's going to be 6, comma, negative 3. And the other one's going to be, what is that? Negative 2, negative 3. So these are the vertices. Next, we find the focal distance. So use your formula. The focal distance 6.4. Again, we know that these focal points are going to be inside the cups, just like our parabola. So from here, we count 6.4. 1, 2, 3, 4, 5, 6.4 is roughly here. So focal point, it's going to be, what is this? So from here, we add 6.4. So 2 plus 6.4, this is 8.4, comma, negative 3. So again, to get this point, it's 1, 2, 3, 4, 5, 6. So we went 6.4 from 2. So 6.4 plus 2 is 8.4. All right, so, and the other one, if we continue this is 7, 8, 9, right? So there is 8.4, comma, negative 3. From here, we go 6.4 from the center. 1, 2, 3, 4, 5, 6.4, roughly here. So the other focal point is going to be, the center was 2, negative 3, so we're moving this way. So 2 minus 6.4, what is 2 minus 6.4? That's negative 4.4. So negative 4.4, comma, negative 3. So again, if you look at this, that's negative 4.4, comma, negative 3. And again, this is called a hyperbola. Hyperbola. So now we are done. Again, the reason why the cups opened left and right is because the coefficient of x was positive. The reason why the cups opened up and down is because the coefficient of y was positive. All right, that's it for today. Have a good day.